Yay, you work swivel. Okay, thank you. All right. We're going to talk about your answer in just a moment, but in today's lesson, this is what I want you to get. Lesson 5-1 was all about the vocab. A monomial, binomial, trinomial, first degree, third degree, all that stuff, cubic, quadratic. The reason I want you to know that is because on this lesson title, what should you be expecting in these problems? It says multiply by monomials. What should you expect? You should expect a monomial, at least a monomial. Now, not just only monomials like you have here, but at least one monomial. This is a monomial, and so is that. So we're just multiplying out, and who has an answer, and they're pretty confident. And we've done this problem, so I like this type, so it shouldn't be too bad. Dalen?
6x squared.
Very nice. 6x squared. Okay, now the reason that's the answer, I'm going to go over why that's the answer and how you can get that, because these expressions are not that simple. Like, that's not our lesson. Okay, what's going on between 2 and x? What's going on between those? So I could have written it like that. Go ahead and do this too. I want an explanation. I want you to know why you're allowed to do it. Then we're going to get to a super important law of exponents, which comes up in a different form in Algebra 2. Same law. It just looks a little different, and they start calling exponents different things, but we got to get these laws down. But here, what's happening with 3 and x? So they're also being multiplied. So that's true, very true. Now, what's going on between 2 and x and 3 and x? What's going on between those two things?
They're both being
Multiply. So don't I have just a string of multiplication here? And what says that I'm allowed to multiply in any order for multiplication? What's that property? Commutative property. So watch what I do here. It's actually, I'm using two properties here. I'm going to do 2 times 3 first, and then I'm going to do x times x. So did I change the order?
Yes.
That's commutative property. Did I change the groupings?
Yes.
Yeah. So that's the associative property. I use both of those properties because what's 2 times 3? 6. Yeah, that's okay. And then what's x times x? And that's how I get my answer. Now, I know you didn't do that. You didn't necessarily go through that process writing it down, but that's the process that makes what you did correct and valid. Okay, let's go to another problem. Go ahead and do this one right here. You may begin. Starting now. Have fun. It's the same thing you're doing on that last problem, except some things are a little bit more. Sorry. If you're multiplying, if you have a negative times a positive, automatically negative. Yeah, and listen, yesterday and the day before we did adding and subtracting, right? So today we're doing multiplying. The rules are a little different, so please don't forget signs and all that.
Is there dividing?
There's division, yeah. We'll get to that after the quiz. Yep. Okay. I'm not going to get the answer just yet. I'm going to go through the process, and then you'll see if your answer is right or wrong. Okay, what's going on between these two?
They're being multiplied.
Now, how many things are being multiplied here technically?
3.
3.
3. 3.
I got a negative 3. I got an x and an x. So how many things right? Sorry, and I meant right here. Yeah, it's negative 3 times x times x. Isn't that what's really going on? Okay, and who can explain that to me right here? What's really being multiplied? Yep, Jimbo.
They're actually
And you can just list them off if you.
8 x, and x.
Okay, so 5 x's are being multiplied. Okay, that's it. And it doesn't matter which order I multiply in.
No.
So I'm going to multiply, and I'm showing the long way. I'm not expecting you to do the long way every problem. In fact, don't do it that way. Because there's a law we can follow. But really I have negative 3 times 8, and then I have okay, yeah. Isn't that it?
Yep.
Okay, what's negative 3 times 8?
Negative 24.
Good, negative 24. That's simple enough. What's x times x times x times x times x times x times x?
X to the 7th.
Good, x to the 7th. And that's your answer. How many of you got that? You didn't have to do it this way, but you got that the first time? Good. You know how you got that? Without going through this process, you followed the law.
Well, we followed the law.
So you add the
How can you break it? How can you break it?
I want to law, but I don't.
You should add them.
Yeah. Okay. Now I understand. I just wait.
Let's look at the law of exponents for multiplication. Okay, questions or comments? Questions I'll take, comments I'll wait for. And is it on this or is it something else?
On that. On the law.
Go ahead.
How do you break this law? Like what goes outside?
So
of
when
it?
you break the law, you're wrong. And just like when you break other laws, you're wrong. You're in the wrong. And some of those laws, I'll be honest with you, some of those laws are like, we did it for practicality's sake. So it's not like if you drove past that yellow line, the whole world ends. But it is going to cause danger with somebody on the other side. This law, though, you mess up, you're wrong. Like, there's no way. No, I'm kind of right. No, you're kind of wrong, which means you're very wrong. I like kind of being right. I prefer to be fully right, and it helps you out practically in many ways. Okay, yes, Dalen.
Can you go back to the problem?
What do you have? What's your questions?
So why couldn't, since it's like x to the second and then x to the third, why can't you just multiply 5 times 2 and do? That's what I could.
Yeah. Okay. So let's look at the law, and then I'll apply it to those problems and see how we got those. Okay. Here's a law. It's an algebra, by the way. A to the mth power. A to the mth power. Yes, mth, th power. You could say a to the m power, but you're going to see it later on, a to the mth power times a to the nth power. And in fact, you see nth power so much, I can't even think of all the ways. Statistics, probability, algebra, calculus, sums, sequences, nth power. Now, if you're looking at this, you're like, what? What does A stand for? A
Unknown.
number. And M stands for
Another
A.
number.
And N stands for
A different number.
whatever it is. And yeah, what's cool is that they all could be the same number, but we're just saying they're standing for numbers.
No, they couldn't be the same number.
They really could. Yeah, I mean, that's what's cool, because you could say A equals M or M equals N or all three of each, but it still applies. Same, they don't usually happen like that, but it's possible. Okay, that would be what results. A to the M plus N. Yeah, and you can see, yeah, that's where it gets tricky. So you say A to the M plus N.
A to the m plus n.
Let me explain this law real quick before we get some questions, because I know it's kind of weird. All right, look at the multiplication problem. What's going on between these two guys? They're being multiplied. Do they have the same base, we call them? The same base. They both have A. They have a base of A. If you're multiplying two numbers with the same base, what do you do with their exponents? Add them together. So, sorry, Henry, getting a little distracting. I can't have that here because I want you guys to get this. Okay, let's look at it with numbers. And I did this with a big set of numbers, but hopefully you'll believe me. Okay, let's go with 3 to the second power times 3 to the fifth power. According to the law, in exponential form, what do you get? 3 to the, according to the law, 3 to the seventh power. Yeah, you add 2 and 5 and you get 7. Okay, that according to the law. Okay, sorry? Great question. So, shouldn't you get 9 to the 7th? Okay, ready? Ready? Let's do it. Let's do it with actual numbers. Like, let's find out. What is 3 to the second? 9. Yeah, 3 times 3 is 9, right? So 9. We're good with that? And what is 3 to the fifth? Now, if you want to go ahead and work that out, be my guest. But I have a friend with me here that will help us do it a little bit quicker. Because, by the way, when you get to exponential notation, the numbers are big. Okay, I'm going to verify it with you guys. Sammy, is this 3? And then that little caret symbol means exponent raised to the fifth power. Okay, that's 3 to the fifth power.
Okay.
Okay, and I'll enter it. What do you get?
243.
Okay, so 3 to the fifth power is 243. and I had it verified. Okay, so I'm going to do 9 times 243. So is that right there? 9 times 243?
Yes.
All right, what do we get?
2,187.
2187. Okay, so by calculator, are we okay?
By calculator.
Yeah. Okay, so we're good with that. Now, what I want you to do, if I wanted you to verify it for real, I just said that 3 to the 2nd times 3 to the 5th is 3 to the 7th, but is 3 to the 7th really that?
Yes.
3 raised to the 7th. Okay, Camille, here you go. Is that 3 with a little caret symbol saying exponent 7?
Yep, that's right.
2,187.
2,187. So do you see?
That doesn't seem right.
It doesn't seem right, but thankfully it is. So are these two the same? Now, notice what happens here. When you multiply two numbers with the same base, you add the exponents, right? You get that law? Did the base change? A, and A. 3, 3, and 3. The base doesn't change, just the exponent. Yes, ma'am.
Is this for only numbers that are the same? Like if it's 5 to the 3rd times?
Oh, so like.
Yeah,
number
not
before-
for other
Oh,
ones.
that's what I was getting confused on.
Yeah, if you had, great question. If I had 3 to the 2nd, 5 to the 2nd, this law doesn't apply because you have different bases. Okay, let me give you another example with variables. What if I had x to the 10th times x to the 3rd? Don't call out. What would you get? X to the 2nd, or excuse me, x to the 10th times x to the 3rd should be x to the, don't say it out loud until I call on you. I think, same.
X to the 13th.
Just x to the 13th. You added the 10 plus the 3. Did they have the same base?
Yes.
So you just add those exponents. You're done. That's it. That's the law. Follow it. Don't lose it. Yes, ma'am?
This is multiplying. We are just adding them.
Okay. If you're multiplying two numbers, so right, there's the multiplication.
Yes.
With the same base, yes, you have to add those exponents. So in order to multiply those numbers, you just add those exponents together. So yeah, you're adding, but it's because you're multiplying like bases. Okay. Begin. Uh-oh, sorry. 10x cubed y times 3x squared y squared. So I want you to multiply those two together. Okay, I'm going to work it out using the properties, and then I'll show you how you can do it on your own. Isn't this just... That's okay. That's all right. That's what my son says all the time. Okay. You're just multiplying everything, aren't you? So does it matter the order? No. I'm going to multiply the coefficients. Do you remember that term, coefficients?
Yeah.
So numbers, the numbers, or you can even say the big numbers of a term. Then I'm going to multiply the x variables, and then I'll multiply the y variables. Oh.
You just gave us the answer.
Okay, what's 10 times 3?
30.
This is 30. I just did 10 times 3. What's x cubed times x squared?
X to the 5th.
X to the 5th. Good, you added those exponents because you had the same base being multiplied. And what do you get for y?
Y to the 3rd.
Third, and remember, y has an exponent of 1. 1 plus 2 is 3. Okay?
1 plus 2 is 3?
Yeah, actually you made me doubt when you said that. All right, anyway, that's your answer. See how easy that is? Isn't that nice? Okay, I'm going to go back. Okay, not yet. I'm going to go back to that one problem, 2x times 3x. If some people, and this is more of the 8th graders, those 8th graders, they're so skeptical on things.
Especially when we are them.
Yeah, don't be like that when you get, I mean, you can question. I want you to question, but don't be skeptical. Is that really true? I know a time where that won't work. A lot of times, the example you gave me is invalid or just flat out wrong. That's okay, I'll be gentle with you. I'll say, that's a great thought that came to your mind. I don't know where in the world it came from, but that makes you unique. Okay. All right, let's look here. I'm going to see if it follows the rule, the law. Do you guys remember I did this? 2 times 3, and then x times x. All right, we know this part, that's 6. But I got x squared. Wasn't it because x to the first, x to the first? Okay, 1 plus 1 is
2.
You've been using this property. it works.
know that. It's such
All right.
a complicated math, you forget the simplest things.
Go. I remember I gave this to them, and they did the same thing. I'm like, I know what you're looking at. You're looking at that little fraction right there.
I hate fractions.
No, you don't. You love them.
That's not terrible.
You do love them. You love them.
I agree. I love decimals.
How about this? How about this? A fraction is a part of a whole, correct?
Yes.
So imagine the world without any parts, just wholes, right? Wouldn't that be nice?
Yes.
So instead of part of the day at school, you stay the whole day at school. Well, actually, you know what? I kind of like that idea. Thank you.
Wait.
Yeah, one day on, one day off. I'm good with that.
Part of your lunch is part of school.
Summer
Is that the whole day? Your lunch
Is lunch the whole day?
It could be, and then math another whole day. I like
No,
that.
what if it's, no, technically.
Thank you, Aiden.
Science. Summer would still be a whole year.
Actually,
And then another whole year of school
no, technically.
with all days holes.
I could live with that.
I had a question.
Swivel. Please record this. Whole day of summer, or whole year of summer. Whole day of whole year of summer.
Yes,
I want a whole year summer.
And they swivel. They said it, not me.
Oh, wait.
All right, let's keep moving. Honestly, guys, we do like parts of a whole. In fact, you literally like it by tasting it. So instead of a whole cup of whatever ingredient, you're getting a half cup. And that half cup makes it not so sweet or bitter or sour, whatever the case is, it makes it taste good. You and I, we literally like the taste of parts of a whole. We like it. And you're like, no, I don't. No, I just,
had a question.
okay, let's hold. Did you guys work this out?
No.
Okay, tell me what you did. I don't want the answer. No. What did you do?
Math.
Uh-huh.
Math.
Colin, did you get this one already?
I finished it, yeah.
Okay, what did you do?
I multiplied 2 negative.
So I hear talking, and I feel like your homework might be increased. I minimize their homework.
Times
Okay?
12.
Okay, good. So you multiplied the coefficients first, and you're like, wait, negative 2/3 times 12. Oh yeah, over 1. What does that give you?
Negative 8.
Okay, negative 8. I got negative 8 with that. So I just,
3 times 1 is 3.
yes.
Yeah.
And then 2 times 12 is 24. 24 divided by 3. Yeah, or you can cross cancel. And so you still get your 8. Either way, you get it. All right, the second thing I really did is I looked at the C and I'm like, is there any other variable with C? No. Is there anything with D? Yes. All right, what's C times 1?
C.
What's D times D squared?
D third. D cubed.
Yeah, D cubed or D to the third.
Got it right.
Good job.
Everybody,
D cubed.
Stella.
And you have just passed the first half of this lesson.
Oh, that's awesome.
What?
Why is there
Teacher's wise Jedi.
Okay, now listen, look. This was so cool. It happened again in the other class. I put the problem up. This is the second half. This is what we're doing. This is a slightly different problem. And someone already called out what to do. My goal is not only to teach you what we're learning today, it's to help you realize you're ready for what's coming up tomorrow or next year because you're like, that's distributive property. Use it. Just be careful to use it correctly. Identify and use. All right. Remember this whole lesson, Tyler? Wasn't it multiply by a monomial?
Yeah.
Okay, so here's my monomial. But this time I have a multiplication by a binomial. And that's okay. I'm going to multiply the 2x by the x and the 2x by the 1. And I'll just show you how I did that. 2x times x plus 2x times 1. All right, what's 2x times x?
2x1.
What's 2x times 1?
2x.
What separates these two?
The addition sign.
Okay, but, and something you need to look out for, Mary Addison, I'm looking at this. I can combine those, can't I? Combine them? Yeah, what do I get?
We get, we can get 4x to the third.
Aiden, what do you think?
It would be,
No, I
It
didn't
would
ask
be.
what it would be. I said, what do you think of what she said?
um,
Okay, good. All right, Mary Addison. Mary Addison. Did you look at these two terms and say, hey, just multiply them?
no.
What are we doing
This-
between them?
Are you maybe add them?
So are we, can we add these two? Can we add them?
Yes.
You can.
Why not?
Because of the
Exponents.
This is x squared, this is x to the first. Can you add unlike terms? No. Can you multiply unlike terms?
Yes.
So don't forget that. This is as far as you go.
So that's the answer?
That's the answer. It's a binomial answer.
What?
That's it. I mean, if you can make it simpler, do it. But in this case, can we?
No.
No, that's it. If they both have x squared or they both have x to the first, then you could have combined them, but they're not like that. Okay. Go ahead and do this one. Thank you, Jimbo, for reminding me. I did erase something from here. Plus 9. All right, there you go. Use your distributive property. Make sure you get the correct signs, correct numbers, correct exponents. A lot to keep track of. All right. A monomial, and again, times a binomial. You distribute. So the reason I distribute, let me give you the reason why you distribute, because some of you are like, can you just make it easier? Can I add these two together, the 3y squared and the 9? No, they're unlike terms. You can't add them. But I still need to simplify. I need to get rid of those parentheses. Well, thankfully I have a term outside. 2y times 3y squared? 6y cubed. So you did 2 times 3, 6. Y times y squared, y cubed. Plus 2y times 9, 18y. Oh, wait. Before I circle that, are they like terms?
No.
Like terms have the same variables with the same, let me say that again. Like terms have the same variables with the same exponents. These are the same variables, not the same exponents. That's it. That's all you can do. Okay. Oh. All right, look in your book on page 135. A little review on geometry. 135, please. There are 2 examples we're going to go through and show you how you apply this polynomial multiplication.
The
hard
hard
copy.
guidebook, the only book that you should be using in this classroom.
Okay, so page 135. All right, do you guys see that green rectangle there? If you're on that page, okay. How do you find the area of a rectangle? What's that little formula you need to know for the area of a rectangle? You have to multiply this times this. Stella back here?
Length times width.
Length times width. You guys agree with that? Length times width. Okay, somebody identify the length of that rectangle and raise your hand and tell me what it is. What's the length, Jimbo?
3x squared y minus x1 squared plus 5x squared.
Good. That is a length. That is a length. Okay, what's the width?
2x squared y squared.
Whoa. Okay. What are you supposed to do with those two if you're trying to find the area?
Multiply.
You're supposed to multiply. Enter the multiplication problem.
Oh, that looks fun.
Oh,
I'm out.
It's actually not terrible.
just write it down. Sorry?
A lot of
It's not terrible. You guys can handle it. But you have a monomial times this time a triangle. 1, 2, 3. So go ahead and do that. Keep your signs straight. Don't forget your law and follow it. Because this law isn't just nice. It makes the problem either right or wrong if you follow it or not. So make sure you follow it so you can get the right answer. Sorry. You're welcome. Okay, I'm gonna call in 3 people. I need 3 people to help me out. I'll call on you. If you're looking at me, I might call on you. Ruth, what is 2x squared y squared times 3x squared y?
6x to the 4th y cubed.
All right, 6x to the 4th y cubed. All right, next, Cole. He just looked at me. He just looked at me, so I'll call on him. What's 2x squared y squared times negative xy squared?
Negative 2x cubed y.
Very nice. Negative 2x cubed y to the 4th. And lastly, wow, a lot of eyes on me. Yeah. Last time in the other class, I said, if you look at me, I'll call on you. Someone was looking at me at that moment, and they went, don't call me. Wow, I feel important.
Just choose.
Everybody's here, Mr. A.
All right, Kaden.
Everyone's here.
Good. Positive. I'll wait. I don't mind waiting. Okay, go ahead.
Positive 2x and sorry, I forgot to multiply.
Okay.
10x to the 4th y to the 2nd.
10x to the 4th y to the 2nd. That's good. All right, now,
Goodness
before I
gracious.
circle it, identify any like terms and combine.
All of them.
Oh, you're right. They all have xy?
No.
Do they all have
No.
x to the same power, y to the same power?
None of them are like terms.
None of them are like. These are off a little bit, like switched around. These are kind of...
That's weird.
All right, look at the next example. Look down at that yellow trapezoid. Does anyone know the formula for the area of a trapezoid?
Nope.
Wait, yeah.
Does anyone know what the formula for... I don't know where it could possibly be, but it might be somewhere in the recesses of the book.
What book?
Yes, Aiden.
It is 1/2 height times B1 plus B2.
Awesome.
And I can say the answer too if you want.
Oh, go ahead.
26x cubed plus 36x
I'm reading the wrong
squared.
thing.
Did I read the wrong one?
Swivel. Am I missing something? I'm
Yes.
looking at that board and like, what's the answer to that? I don't even see a problem up there. There can't. Is there invisible ink? Okay. Anyway, let's go to the problem first. Then we can come up with an answer. Okay. Let me explain some things about the area of a trapezoid. First of all, A stands for area, and it's 1/2 times the height. And then here's where people get confused. What's B with the little 1 underneath and B?
Subscript.
Yeah. So we say B sub 1 plus B sub 2. Sub underneath subscript. Good. So what are we referring to? The first base and the second base. Now, if I'm looking at this book, which one's the first, which one's the second? Look at the base and the base.
5x squared.
Yeah, that's one base, right?
Wait.
And then what's the other base? 2x squared. So one of them is 2x squared plus 3, and the other one's 5x squared plus 9x minus 12. The reason why is this, look at it. How many of you believe that as you're looking at this diagram, 5x squared plus 9x minus 12 is on the bottom? How many of you can say that's on the bottom? Watch me, Swivel. Okay, ready? Whoa! Same shape. What's on the bottom? 2x squared plus 2. Which one is on the bottom?
It doesn't matter.
It doesn't matter, and here's why it doesn't matter. Look at it. B sub 1 plus B sub 2. Do you really have to add in that order?
No.
Because of what property?
The commutative property.
It doesn't matter which one you put where, but one of them's the first, one of the second. It doesn't matter. All right, let's fill in the numbers. A. All right, the height, though, that's pretty clear, is 8x. That is 8x. It's the definition of the height of a trapezoid is the distance between the first base and the second base that forms a perpendicular line. All right, so that's why it has that right angle. That's just a definition. All right, and then they do this. The first base, I'm going to call it, they call it 2x squared plus 3. I'm going to call it 5x squared plus 9x minus 12. So 5x squared. So write this down, please. 5x squared plus 9x minus 12. And then the other base is 2x squared plus 3. So 2x squared plus 3. Okay, now, is this one of the bases?
Yeah.
Is this another one of the bases?
Yeah.
Are they being added? Now, they put a set of brackets. The reason they do that is because if you're following order of operations, don't you have to do what's inside the brackets first?
Yeah.
And then what's inside those parentheses, and then you work your way in. So here, what do I have to deal with first? I have to add, ooh, I'm losing you guys. Okay, I have to add these two polynomials together, but are there any like terms in here? No. Any like terms in there? Yeah. So just add these polynomials together, just like we did in 5-4.
5x squared and 2x squared are like terms.
Good, these two are like terms, so what's 5x squared plus 2x squared? 7x squared. Good. I have a 9x and no x, 0x. That gives me 9x. I have a negative 12 plus a 3.
Negative 9.
Negative 9. Good. So that's a review of what we did already. All right, that's what I have. But I still have that first part. Okay, I just did the parentheses. There's nothing to do in there. That's as far as I can go. So what's my next step? Left to right, I have to multiply left to right. So I have to multiply 1/2 times 8x. 1/2 times x. Yeah, and if you're like, what do you mean by that? What is half of 8x?
4x.
Then you do.
Yeah, then I'm like, wait, I'm stuck. I can't multiply just these two. Oh, but I can distribute. Okay, go ahead and do that real quick, and I'll ask 3 more people to distribute that.
I don't get any of it.
Have you written anything down? Just write it down. Just write what I'm writing down.
I don't get what I'm writing down.
I wouldn't get it either if I didn't write it down. I'm trying to give you a way just to write it down. Okay, Caroline, what is 4x times 7x squared?
28x to the third.
Good, 28x to the third. Camille, what is 4x times 9x?
36
Positive 36
x cubed squared.
squared, good. 36x squared. Ruth, what is 4x times negative 9?
Negative 36x. Whoa, what's that?
I get a trinomial. Do I have any like terms?
No.
That's my area of my trapezoid in this case.
Are we gonna have to do that on our homework?
Well,
Please no.
I got it right.
depends how long. It depends how quiet you guys are. You had some good times and you had some rough times. So stay with me. Almost done. But listen, if you don't get the process, I would at least just write what I'm writing down, and then you can think about it as you go. But if you don't even have the process down, you'll never get it. That's really hard.
Well, I don't usually at the beginning, like the B.
Oh yeah, the B sub 1, B sub 2.
Yeah. And how did you get that there with just that?
Yeah, the diagram gives me all of it. Look at the what is it? The bottom. See that bottom of the trapezoid? What is that? 5x squared plus 9x minus 12. That's one of the bases. And then the other base is 2x squared plus 3. The top.
And then you just, why did you put 8?
Oh, this right here. Sorry, this is a formula. So this is something they'll give to you. Yeah, and then you put in the numbers. No, you should either know it or they'll give it to you. And that's separate. All right, 15 of you need to get this last problem.
All right. Okay.
One step at a time. Don't just look at it and say, I can't do it. No, look at it. I have a monomial. I have a I have a monomial, I have a trinomial.
A long number.
What? A long number.
That's
Very, very long number.
And then I don't have any like terms in the trinomial, so I'm stuck with
Then you distribute it properly.
distributed property, which makes it simplified. No more parentheses, no more like terms. That's what we want. Just be very careful with your signs.
Oh.
Okay, I'll start asking people certain parts. Cole, what is negative 2r to the fourth s squared times 7r cubed s?
Negative 14 r to the 7 and s cubed.
All right, good. That's the first term.
Okay.
Jimbo, what's negative 2r to the fourth s squared times 4r to the fourth s cubed?
Negative 8r to the 8th, 7 to the 5th. S to the 5th.
That's okay, that happens. All right, and then Stella Sandstrom, what's negative 2r to the fourth s squared times negative s squared?
Positive 2r quad,
To the fourth?
yeah, and s to the 4th.
You really want it to be quad, I get it.
Quad R.
Are there any like terms though?
No.
Yes. Yes.
No.
Right.
None.
Here, I reduced the homework for them, I'll do it for you, and it was at the bell.
Good.
So write that down, you're welcome, thank you guys.
Thank you for reducing it.
Yes.